this demo, we are showcasing how ILI, the inline inspection tools, detect internal pipeline defects such as cracks, metal loss, and dents, and how this dashboard turns that complex inspection data into a complete integrity story. We have structured the narrative across three layers: the anomaly detection and validation, fleet and cross-pipeline intelligence, seasonal, regional, and operational context. This helps move from what the tool found to where the risk is concentrated across the fleet, and finally to why those anomalies are occurring. So page 1, which is the ILI anomaly detection and validation, focuses on what the ILI tool detected in a specific run and how reliable those findings are. As we can see here, the different slices, the year, run ID, anomaly, flag, feature type, based on which we can filter and see the different data. And then comes the banner, which summarizes the story for the selected year, run, and feature filters. For example, in this case, it says that for the year 2024, anomalies increased by 158%, driven primarily by the crack features. Then comes the 5 metrics, the high severity features, which gives us the count that require immediate actions, the new feature appearances, emerging threats not seen in previous runs are shown here, total anomalies, which gives us the overall defect volume, average confidence score, which indicates how confidently the tool classified the defects, and the tool change percentage, which shows run-to-run variation in anomaly density, a proxy for inspection consistency. So these KPIs give an instant snapshot of risk escalation and tool reliability. Then comes the 5 visual charts. The first one being the anomaly count by run and feature type, which basically compares the different feature types like the cracks, the dents, and the metal loss across different runs and identify which is trending up. Next is the CP stability spark line, a color-coded time series, which shows when the protection was normal, when the protection was out of range. As we can see here, the yellow line indicated the out of range protection, and the green one shows the normal protection of the cathodes. Next is the feature geometry fingerprint. Each dot is a feature, and the color indicates the risk from the normal to the high risk. So we can see here the top right quadrant shows the dangerous and deep long anomalies. The dangerous are the red and the orange ones. Blue is the normal one. Next is the severity breakdown donut, which gives the severity proportions as high, medium, and low. And then comes the run-to-run anomaly timeline, showing the increase or decrease in anomalies across the different runs. So here we can also change the different sliders and see the change in the result. We'll move on to the fleet and cross pipeline page. Fleet and cross pipeline anomaly intelligence. Here we see the banner, which gives us a fleet narrative before we dive into the different visuals. So the first KPI is the pipeline with anomalies, which shows the count of pipelines that have at least one anomaly, which tells you how widespread the issue is across the network. The total fleet anomalies aggregated count across all pipelines. Paired with slicers, this acts as a quick overall risk burden metric. Next is the tool change percentage, which shows how much anomaly density changed from the previous run. If it's sharply high, it may indicate. Next, the pipeline most affected, which identifies the single pipeline contributing the highest anomaly load that needs immediate prioritization. dominant feature type summarizes which defect type is dominating across all pipelines, whether it is crack, dent, metal loss. So this indicates fleet level defect signature. Next comes the different visuals. The first one, which shows the fleet anomaly heat map, which highlights the high risk pipelines instantly. And here we can see the red ones are the high risk zones, the brown ones are the middle ones, and these lighter ones are all low risk zones. Next is the tool capability versus anomaly density, which basically tells us, did UT detect deeper features than MFL? Which is better? Which tells us which one is better? Or does a specific tool correlate with higher crack detection? Are certain pipelines under inspected due to technology mishaps? These kind of things can be figured out using this graph. Next is the amplitude band distribution, which shows high versus moderate amplitude signals. High amplitude bands often correlate with crack-like signature, sharp signals, higher repair priority. Next is the waterfall chart, which by the feature category, which shows how much each feature type contributed to total anomaly growth. Classify whether growth was driven by crack features, metal loss, dent formation, or a combination. So anomaly load by the pipeline age group. The last visual shows the distribution of anomalies across old, mid-age and new pipelines. That is according to the construction year, which is the oldest and which is the newest, and the anomalies across these pipelines. So which helps justify pipeline replacement or rehabilitation strategy. Next, we move on to the seasonal, regional, and operational context intelligence. This page explains why anomalies behave the way they do by combining season, region, and operations data. We see the topmost banner, which is basically the summary of the whole page. So next comes the different KPIs. The most important one being the region with anomalies shows how many distinct regions recorded anomalies. A rise indicates spreading geographical risk. Next is the regional hotspot severity index, which is an aggregated severity score per region, factoring the high severity count, depth percent, growth rate, and the feature densities. Higher values indicates higher risk. Next is the average CP stability region wise. Average CP protection level using CPMV values. Low CP, more negative implies possible corrosion environment. Seasonal anomaly lift percentage, which shows change in anomaly counts between seasons, example winter to monsoon, and negative indicates a seasonal deterioration. Next is the operational event impact score, which is weighted score based on the peaking interval, maintenance events, throughput levels, and the pressure changes if applicable. A high score means operation disturbance may be increasing the anomalies. Next comes the different visuals. First one is the operational load trend. Shows month-wise operational stress with smoothing. Helps identify if high load precedes anomaly spikes. Next is the seasonal anomalies by season and region trend. Shows how each region behaves across season. So we have different season: winter, monsoon, post-monsoon, and summer. So the trend is seen across the different seasons. Okay. We'll select one particular year and see the data. See? Okay. Next comes the operational event timelines, which plots operational events by month. When placed under anomaly trends, correlations become visible. So we can see here for Jan 2024, what are the operational trends shown here or being calculated. Region into month contribution. This chart basically highlights which months each region contributes more anomalies, useful for seasonal intervention planning. While regional hotspots by feature type shows cracks, dent and metal loss composition per region. And this identifies type specific regional risks. So across the 3 pages, this dashboard moved from ILI detection to fleet intelligence to the seasonal and regional operational context. So which equips the operators and decision makers with the insights needed to understand not just what the anomalies exist or where the anomalies exist, but why they are occurring and where to act first. Thank you.